Let's get started with one of the examples that we have. So if you go to the Getting Started tab, we have prepared a couple of examples. If you select one of these examples, like for example the quick start demo we're going to select now, there will be a data window popping up, that's this one, and you will have a small description about what the dataset is and what some of the lessons are that we can learn from that. In this case, I want to keep things easy, so I will go relatively quickly through these, through the different tabs, just to keep the speed going. I will go into the individual settings in the future examples. So if you select one of these templates, all of the fields in these tabs have also been filled in for you. So if we now go to data settings, we now have an example or a test data set, which is the one you see on the right hand side here. And we have the correct configuration for the data loading. Now, if you want to make some changes to this, you can either make them here directly. If you make a mistake, the editor will tell you that there is a mistake. You can hover over these mistakes, and it sometimes brings up a tooltip to tell you what you've done wrong. But whatever you do, if you want to change the data range or something, whatever you do, once you've made one of these changes, I recommend to save the configuration, because only by saving the configuration will you be able to use it later for your batches of files. So we're really just editing the underlying YAML configurations in this. Anyway, I will go through each one of these things later on. But for now, let's keep this thing going. So the run settings have been filled out. We are using one of the SAS models here. That's the sphere model. It's the most simple model that you have. You have at your disposal the entire SAS models library. Well, that's not quite exactly true. You have those models of the SAS models library that specify a volume. Because the way McSAS works is by volume weighting of your individual contributions. And that means that all of the models that define a volume can be used over here. So we can use, for example, sphere. We can also add a structure factor, and you see, as soon as you fill in one of these things correctly, it will actually give you some information in the panel below here. You can also add models to that. So again, it must have a volume. So a model like a cylinder can be used. You can go wild with this. And things will get just harder, much harder for both for the optimization engine and for you. So I always recommend keeping it simple in the beginning. We'll go through the rest of these parameters in the next example. But if you just want to test your configuration on the data that you've loaded, you can actually click this button and it will do a single optimization. It will show you how fast the reduced chi-squared has optimized. And if your uncertainty estimates were realistic, it will optimize to a reduced chi-square of 1, in which case it will stop, because that is the stopping criterion for this. The data plot now will also contain the fit to your data as a red dashed line. It's very hard to see in this case because it exactly overlaps this simulated data set. Now, this quick start demo is the only simulated data set that we have over here. It was the one that was originally in McSAS 1, which is why I've also included it here as the first thing to start with. So once you're satisfied with your test and once you've saved your configuration files, you can now load in your files either by clicking this button or by dragging and dropping your files into this table. You give it your read-in configuration, you give it your run configuration, and then you can click the run start optimization. You see in the terminal that we have, we actually do get some updates on these optimizations once the optimizations are complete. If you have multiple files, it will actually run just one after the other through these files. But what has happened now is that for every one of these files, you have a McSAS optimization file as well. This is just a file name with an underscore output.hdf5. I will probably change the name at some point, but in any case, in that HDF5 file is everything you will ever need. So it's the original data, it's the the rebin data, it's the run settings, individual optimization results, and so on. And it will eventually also have the results from the histogramming. So the optimization is one thing. You now have a set of 300 spheres, which can, if you volume weight them, they can actually describe your data. But you want to visualize that, and you usually want to visualize that in the form of a histogram. The most simple histogram is the single histogram. This, of course, only has one histogram entry in the YAML editor, but you can have multiple histograms, or you can have as many as you like. We've had users who had like 10 or 15 different histograms tacked onto there. But I like to keep it simple, right? So again, we can test this configuration. In this case, the test file has been filled out for you in the template. Again, the original file name underscore output.hdf5, and now we test the histogramming by clicking this button, and it will open a PDF for you. In this PDF, the leftmost window is always the data and the fit. The blue data points and data line are completely swamped by the orange fit line. You can see one of the advantages of McSAS here, that it can fit data really, really well. And on the right-hand side, we see the output histogram, the different populations that we get whenever we histogram the 300 contributions we have. The uncertainties that you see over here, they come from the individual independent repetitions that we do. So in the next examples, we'll actually go a little bit more in detail about what it is that you can configure and how you can do that. I just want to leave you with this tab. If you ever have, if you only have one data file, then you can stop here. The PDF has been generated. The histogramming information has been written out to this file as well. So if you delve into this HDF5 structure, you'll find all of the information that you want. But if you have multiple files, this interface will run that histogram configuration on all of those files. Important to note is that if you want to change your histogram settings, if you say, okay, well, I'm quite unhappy with what that looks like, I've changed some of the parameters, or I've added some histograms, you don't need to redo the optimization anymore. That was a problem with the original McSAS. That's been resolved now. Now you can just rehistogram an existing optimization because the underlying population of 300 contributions has not changed. So now you can see again, we have the data plot, we have the original histogram, and we now have an extra histogram here. Note that if you change the axis from logarithmic to linear, that also means that the spacing between your bin edges change, and therefore the height and the shape of these peaks will change, because the number of contributions in each histogram bin has now changed as well. On top of each of these, you will see the population statistics for that particular range that you have selected in your histogram. So you have the total value, which is helpful in case you want a total volume fraction of a particular population. You will see also the 4 modes of the population. That means the mean radius in this case, parameter value, right? The mean parameter value. The variance, so if you want to know the width of the population, you take the square root of the variance, and then you have the width in form of a standard deviation. And the skew and kurtosis. Skew and kurtosis tell you a little bit about the shape of your population, although I have never used that in practice. But the information is there if you need it. Everything with uncertainties that have been derived from the multiple independent repetitions. So that's all for now. I will, I will see you for the next example.